This lesson will be focused on logarithms, and it will provide an introduction to logarithms. A logarithm is a synonym for index, for a power, or for an exponent. For example, we have 3 squared is equal to 9. 3 raised to the second power is equal to 9. 2 here will be the logarithm because 2 represents the index, 2 represents the power, or 2 represents the exponent. So therefore 2 here is our logarithm. Now we're going to write 3 squared equals 9 in logarithmic notation. So how do we do that? Remember that we identified 2 to be the index or the logarithm. The logarithm of what is equal to 2? In math, we say the logarithm of 9 with a base of 3 is equal to 2. So 9 in our index form is our answer. The logarithm was 2 and the base was 3. So in logarithmic notation, we say a logarithm of 9 with a base of 3 is equal to 2. And it is written in this manner. Log base 3 of 9 equals 2. Let's convert the following from index form to logarithmic form. So we have x raised to the power of 3 is equal to 8. First, we already know that our logarithm is 3. So whatever comes on the right side of the equal sign will be 3. Identify your base. X is your base. And then our solution is 8. So we will have the logarithm of 8 with a base of x is equal to 3, as we see right here. Now we have in index form that 5 raised to the negative third power is equal to 1 on 125. We know that negative 3 will appear on the right side of the equal sign because this is what our logarithm is. But the logarithm of what? It is the logarithm of 1 over 125 with a base of 5. The reverse can be done where we go from logarithmic notation into index notation, and sometimes this is useful when we need to find unknowns. For example, we have the log base 10 of 5 is equal to x. To place this into index notation, the power is x, the base is 10, and it is equal to 5. We have the log base 8 of 64 is equal to 2. So we know that the base is 8 and the logarithm is 2. So 8 raised to the second power is equal to 64. We can also evaluate our logarithms. So for example, if we have the log base 3 of 243 and we are asked to find what value is that? So we should ask ourselves, what is the power of 3 which results in 243? And if you think about it, you need to multiply 3 5 times to get 243. So that power must be 5. So log base 3 of 243 is 5. Now we have another example. Log base 2 of a quarter is equal to y. So in other words, we are trying to find what is log base 2 of a quarter. Again, we ask, what is the power of 2 that will give a result of a quarter? Now remember, the negative index causes us to get the reciprocal. So whatever index we're looking at or whatever logarithm we're looking at must be negative. So let's look at 4. 4 is when we square 2. So therefore, the logarithm we need must be negative 2. And this is how we evaluate logarithms. What we have noticed is that our logarithms have different bases, but there are some common bases that we use, and these are what you will find on your calculators. For example, base 10. When we are working with log base 10, usually we do not write the 10 as a base beneath log. We just leave it blank. So whenever you see log of a certain number, it is assumed or it is understood that the base is 10. Another common base is E, which is called Euler's constant, which is a special constant in mathematics, and it is also an irrational number. Logarithms with a base of e are usually called natural logarithms, and it will be written in the following form. Instead of log base e, we simply write ln. So ln 10 is said to be the natural log of 10. That function you will also find in your calculator. Now, there are some facts from logarithms that will be very useful when we go into the next lesson. The logarithm of 1 to any base is 0. Keep in mind that in indices, you learned that any number raised to the power of 0 is always equal to 1. So, in logarithmic form, that would mean log of x, and x represents any base, of 1 is always 0. The second fact is that the logarithm of a base is equal to 1, meaning that if you have a base, log base x, and then you're finding the log base x of whatever x was, your answer will be 1.